So in the last class, lecture number 1 of septic tank, we have seen how to do the quantity calculation of septic tank in the rectangular portion and in the circular portion of the soak pit, right? So these components, whatever the components we are seeing here, this is the rectangular component of septic tank and this is the circular soak pit. So these are to be constructed inside the ground level below the earth surface. So these are the indication of earth surface which you have seen in the last class, right? We have calculated earthwork excavation using this plan and cross section of rectangular portion and using the plan and cross section of soak pit, right? We have calculated the earthwork volume and we have calculated the earthwork volume required for construction of soak pit. So that was total 19 cubic meter, right? As we can see, the width of CC bed is 280 centimeter and width of CC bed. So this is length of CC bed and this is width of CC bed is 1.7 and height of CC bed below the height of earthwork excavation below the earth surface, that is 1.95 meter. So the total earthwork excavation for rectangular component of septic tank is 9.28 meter cube. Similarly, for soak pit, right? So upper portion of the soak pit is for 3 meter and lower portion of the soak pit is for 20 centimeter, that is 0.2 meter. The total quantity including all these things is 19 cubic meter. Similarly, concrete in the CC bed and flooring is 1.04 cubic meter and first class brickwork in the rectangular portion of the septic tank is 2.78 cubic meter and second class brickwork in the soak pit at upper portion and lower portion is 0.53 cubic meter and second class dry brickwork in the middle portion of soak pit is 1.88 cubic meter. Similarly, so roof cover slab at the rectangular portion of the septic tank and circular portion of the soak pit, it is 0.234 cubic meter and 0.115 cubic meter, which you have seen in the last class. Similarly, there is a baffle wall, that volume is 0.018 cubic meter. The total concrete quantity of roof slab cover at the rectangular portion of the septic tank and soak pit as well as baffle wall, including all these three components, the total quantity is 0.367 cubic meter, right? So today we'll see the remaining calculations related to plastering inside the septic tank. Right, so there are four walls of the rectangular portion of the septic tank, right? Two walls are long walls and two walls are short walls, right? So all this open surface of all four walls has to be plastered, right? So as you can see, the inner dimension of septic tank which is having 200 centimeter, this is the inner dimension of long walls 200 centimeter and width of short wall is 90 centimeter. So these walls, right, these are the inner dimension of long walls. In other direction we'll be having short walls, right? These are to be plastered for height total of 170 centimeter height, that is nothing but 1.7 meter height, right? So this is the overall height which has to be taken for the plastering purpose, right? We cannot take this total height, this will become more than 170. Similarly, we cannot take this height, this will become less than 170. So that is why the average height, that is 170, is taken for the plastering area calculation, that is the total plastering taken in square meters, right? So length of two walls, long walls is 2 meter, two surfaces, right? So height is 1.70, total quantity is 6.80 for two long walls. In shorter direction there are two short walls which are having 90 centimeter as width. Similarly, both are having height as 1.70, total quantity is 3.06, right? So adding together, this is the 9.86 is the total area of plastering, right? Similarly, we'll consider the floor plastering of 20 mm thickness at the bottom of septic tank, that is sloping floor has to be plastered, right? So this sloping floor plaster is done in square meter, that is total length of sloping floor multiplied by width of sloping floor. As we can see the open space in the rectangular portion of the septic tank, where water will come and store here, right? So where solid material will come and store here, right? This is the total area which has to be plastered. This is width and this is total length which has to be plastered for 20 mm thickness. This is the total area of plastering inside the septic tank. So this is to be plastered, right? So this area is calculated as total length, that is 200 centimeter, which we can see here. This is the 200 centimeter, right? And width is 90 centimeter. The total area is 200 by 90 centimeter is the total plastering at the floor of septic tanks. That is the plastering area they have calculated here, right? In the soak pit we are not doing any kind of plastering, as the water is infiltrated to the ground surface, right? So in the soak pit there is a 50 mm brick aggregate in the outer periphery of the soak pit, right? So we'll try to calculate the 50 mm brick aggregate in the outer periphery of the soak pit, right? So that is this portion I'm talking about. This is the portion I'm talking, right? This is the shaded portion, brick aggregate, which is having 15 mm thick, right? So in plan we can see this is the portion which is to be calculated. So now to calculate this value, so we need to calculate the center line length, that is the circumference length, right? That circumference length is calculated like this: half of the 15 on both sides, right? Total inner diameter is 100 plus this 20 plus this 20, and half of the 15 this side, half of the 15 this side, right? Half of the 15 this side, half of the 15 this side of the brick aggregate, right? The total 100 plus 20 on both sides, it is 140, plus half of the 15 on both sides, that is 155, the diameter which is taken for the calculation of volume of brick aggregate. Height of brick aggregate is extended for 250 centimeter height. This is the total height, and this is the average diameter which has to be taken for the calculation. This is the average diameter or center line circumference length. So this is the center line center diameter for the brick aggregate calculation, right? So half of this, right? 100 plus 20 this side, 20 this side, half of brick aggregate here, half of brick aggregate here, right? So this is total is 100 plus 20 on both side, 140 plus 7.5 plus 7.5. This is 155 diameter. So that is the diameter they have taken. Pi multiplied by d will give the circumference, multiplied by the 15 centimeter width, multiplied by the 2.50 meter height, right? Pi d will give the circumference. Pi multiplied by 1.55 diameter, multiplied by the 15 centimeter thickness, multiplied by the 2.50 height. So that will give the volume of brick aggregate that has to be filled. So it will be equal to 1.8 meter cube. Similarly, at the bottom of soak pit, so there is a complete filling of the brick aggregate in this portion. This is the brick aggregate is to be filled completely in order to filtrate the water coming from the top portion. This is taken as 1.01 diameter, right? Since it is to be filled completely, it has to be calculated here as area multiplied by thickness. Pi by 4 multiplied by diameter, that diameter is taken as 1.01 meter, right? Pi by 4 multiplied by 1.01 square, that will give the area multiplied by this thickness. So this will give the volume of brick aggregate that is to be filled in the bottom portion, at bottom of soak pit. So this is pi by 4, 1.01 square is the diameter, and thickness of brick aggregate at the bottom portion is 20 centimeter thickness, that is zero point 0.2 meter. So the total quantity is 0.16 cubic meter. Altogether it will be 2 meter cube of the 50 mm brick aggregate in the soak pit, outside of the soak pit and bottom of the soak pit. So it is of 2 meter cube. Similarly, coarse sand at the outer portion of the soak pit, right next to that big brick aggregate. So we will be able to see the coarse sand at the outer portion of the soak pit. This is the coarse sand what I am trying to mention. So this is the coarse sand. So these are to be filled at the outer portion of the soak pit, right, which we can see in the plan here, right. This is the outer portion of the soak pit. So this is to be filled with the coarse sand for height of 2.5 meter, right. So now we have to calculate the diameter circumference. To calculate the circumference, we have to calculate the center line length, that is center diameter, that here to here. But this is the diameter which has to be calculated. That is nothing but, so it is 100 centimeters inner diameter plus 20 on both sides. It is 140 plus 50 on both sides. It is 170. 170 plus 7.5 this side, 7.5 this side. It is 185. 1.85 from here to here, from middle of this course end to middle of course end on the other side. So average diameter, right, 100 plus 20 here plus 20 here, 140 plus 15 here plus 15 here, 170 plus half of the 15, half of the 15 this side. Total it will become 1.85 meter as the diameter. Pi multiplied by d will give the circumference multiplied by width, 15 centimeter width multiplied by 2.5 meter height. So that will give the coarse sand in the outer portion of the circuit. That value is 2.18 meter cube. Similarly, so these are the number of components which we can see in the septic tank. Those are iron footsteps. We have to identify how many number of iron footsteps are there, and we have to identify how many number of pipes are there of what meter length, and we have to identify how many number of T's, how many number of bends, and how many number of CI ventilating pipe and ventilating cowl. So let us try to identify how many number of iron footsteps are there in the septic tank in order to get inside the septic tank for the cleaning purpose. Right, there are one number, two number, three number, and four number of iron footsteps are there inside the septic tank. So these are the iron footsteps, four numbers which as mentioned here, right. These are the four number of iron footsteps, right. Similarly, so the water pipe which is connecting from uh, outlet of the latrine to inlet of the septic tank, so that is having total as 3 meter length, right. So latrine to inlet of the septic tank which is mentioned in the question itself, right, that is the total length of pipe which is connecting from outlet of the toilet to inlet of the septic tank. The length of connecting pipe from latrine sheet may be taken as 3 meters. This is the one pipe that is mentioned here. And similarly, the pipe which is connecting from septic tank to soak pit, this is also 3.3 meter. Right here, the clearer distance is 300 centimeter, that is 3 meter plus 15 centimeter this side, 15 centimeter this side, right. So total is 3.3 meter. So that is the another pipe which is mentioned here, right. Outer end of septic tank to the soak pit, 3 meter clear distance plus 15 centimeter of the insertion on both sides, that is total as 3.30 meter is the total length of pipe in running meter, right. So including both, so this is the 6.3 is the running meter of pipe. Similarly, we can see the one T which is connecting from septic tank to the pipe which is running between septic tank to soak pit. So this is the one T they are mentioning. This is one T which is connecting from septic tank to the pipe which is going out of the rectangular portion of the septic tank to the soak pit. And there is one bend. which is connecting like this. So this is one bend and one T which is taken into the consideration. So there is a sewer SWT, that is 100 mm dia, 1 in number. Similarly, CSW bend 100 mm dia, that is in 1 number. Both are taken as it is. Similarly, there is a ventilating pipe which is having 2 meter length, so that is in 1 number, and there is a cowl, that is cowl at the ventilating pipe, which we can see here. So that is the right 50 mm dia CI ventilating pipe for, it is actually 2 meter height, not 2 mm, it is 2 meter height. 50 mm dia CI ventilating pipe, cast iron ventilating pipe for 2 meter, and there is a one cowl, right? So these are the things which are mentioned in this abstract of quantity table, right? These are the 2 meter running pipe, and this is the one cowl. Next is to calculate the estimated amount. For that, we'll follow the abstract of estimated cost table, right? In this cost table, we'll mention the all quantities which are calculated previously, and we'll multiply the rates for this calculated quantities, right? As you have seen the number of quantities which are calculated in the abstract of estimated quantity table. So these quantities are mentioned again, and these are multiplied with the respective rates. These rates are taken from the SR book of different regions. There are 3 different regions in Karnataka. That is, one is Bangalore region, another one is Ballari region, and Belgaum region. Right? In all these 3 regions, the PWD department will announce the standard rates for labor charges. Right? According to that rates, we have to take those rates for the calculation of estimated amount. So quantities we can calculate from plan and section. Those quantities are multiplied with the rates which are shown here, right? So by multiplying these rates for each and every activity, at the end we can get the total estimated amount as 2711.27 rupees, right? For this we have to add the 3% of contingencies and 2% of work establishment charges by default, right? That rate is 135.56 rupees. Including all this, we can get the total amount as 2847.00 rupees for septic tank of 25 users, right? So this is the total estimation of septic tank, right? So this is about the estimation of septic tank, right? We'll see in the next class.